Okay, let's go ahead and figure out what the cosine of 300 degrees is equal to, and we're not going to use a calculator. Now, obviously, if I said, hey, go ahead and get your calculator out and plug in 300 into your calculator, just find the cosine of 300 degrees, that would be super easy. Almost all of you out there could do this as long as you had a scientific calculator. But the question here is more towards your understanding of evaluating trigonometric functions. So, this type of problem is a problem you would see in a trigonometry course or a course like pre-calculus. It's pretty common these days to have your trigonometry portion. If you're like, hey, I want to take trigonometry, typically, well, it's far less common to be able to take a standalone trigonometry course. Some schools offer trigonometry in that manner, but typically, trigonometry is part of a larger course like pre-calculus. So, like a good third or maybe even up to a half of a pre-calculus course could be like trigonometry, and that's what kind of used to be offered as like a semester course. But it's a lot of concepts covered, about trigonometry inside of pre-calculus, for example. Okay, a lot more advanced concepts than just basic right angle trigonometry. So if you're at this particular level, whether it's trigonometry or pre-calculus, this is absolutely a problem or a type of problem you're going to need to be able to solve. So if you think you can figure this thing out, go ahead and put your answer into the comment section. I'm actually going to show you the correct result here in just 1 second, and then I'm going to walk through the basic solution to this problem. But before we get going, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades. It is my true calling to teach mathematics. I love teaching mathematics, and I can tell you right now, all of you could be successful in mathematics, even those of you that are struggling in math. Now, if you are at this particular level of math, a lot more students tend to struggle because just, it's kind of normal. If math is kind of like climbing some stairs, right? So let's say you were super good in elementary school, then middle school math, you were great, and then you took up pre-algebra or algebra 1 and geometry. The more advanced in terms of the math you're taking, the more challenging it's just naturally going to get. So if you're at the pre-calculus level or trigonometry, it is going to be challenging just about for almost all students. So if you're like, oh, I used to be really good at math, but now this is kind of hard, well, that's kind of normal, right? So the way to address that is just continue to keep working harder, okay? But not only do you want to work hard, you want to work smart. And the main thing to be successful in mathematics is to have access to great math instruction, clear, understandable, and comprehensive. So if you need help in your current math course or maybe some sort of special test that you're studying for, something like the SAT, ACT, GRE, GMAT, ASVAB, teacher certification exam, anything with a math section on it, or if you're homeschooling mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span these categories and much, much more. I'm also going to leave links to my math notes in the description as well. It's just really, really common that students don't take adequate enough notes. Okay, they take some notes, but you need to make your notes as perfect as possible. Become a great note taker, and you will do very, very well in all your courses, not just mathematics. So you can use my notes in the meantime as you improve your notes. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and figure out the answer here. Cosine of 300 degrees is equal to what? Again, we're not using our calculator. The cosine of 300 degrees is equal to 1/2. Okay, so that is the answer. Well, how did you do? Again, you didn't use your calculator, right? Well, if you got this without the aid of your calculator, let me give you a nice little happy face, an A plus, a 100%, and a few stars to celebrate your success in trigonometry. Very, very good. Okay, so now I'm going to go ahead and explain this, and I'm going to I'm going to come at this as with the assumption that you already know a decent amount of trigonometry. Okay, if you're new to trigonometry and you're trying to tackle a problem like this, this might be not the right level to start learning trigonometry. But if you're just interested in trigonometry, I think you could just stick around for a couple more minutes. I think you'll understand this explanation as well. But again, if you're in a pre-calculus course or trigonometry course, you should understand some of these basic concepts that I'm going to explain right now. And of course, anything you don't understand, and if you're at this level of mathematics, I'm going to highly suggest that you check out my pre-calculus course. All right, you're going to learn everything and much, much more that you're going to need to know about trigonometry, pre-calculus, etc. Okay, so let's go ahead and get into this. So the cosine of 300 degrees. So the first thing we want to think about is this, all right? We're thinking about the cosine of 300 degrees. So you should be familiar with the cosine graph, okay? And this is the basic cosine graph. And the point here I'm going to get to is let's figure out the sign of this answer, all right? You should know this. This should be part of your notes. But is our answer going to be positive or negative, okay? Well, let's just kind of think about that for a second, and let's just maybe think about the value, what could be possible values of the cosine of 300 degrees. Now, hopefully you're familiar with the graph of cosine. This is the basic graph. So it starts here at 0 degrees, and it goes like this. This is one period, okay, one wavelength of the graph, okay, not to be confused with the sine graph. So at 0 degrees right here, we're going to start with an amplitude or value of 1. Okay, now hopefully you understand what I'm talking about. If you're at this level of math, you should already know how to graph cosine. But anyways, if you didn't know, this is what the cosine graph looks like. So as we continue on, we're going to start from 0 degrees and we're going to go all the way out to 360 degrees. And cosine, like sine, these are what we call periodic functions because these are just cycles that just continue to repeat on and on and on, right? So this graph just goes like this and like this. So let's go ahead and walk through what these values here. So at 90 degrees, this is where our graph is at, okay? Pi over 2 radians or 90 degrees, it's at what? 0. So if you want to kind of get your calculator and just kind of verify this, you can plug in cosine of 90 degrees, it's going to be 0, or cosine of pi over 2. These are common angles that you should know. All right, so how about right here? We're halfway through the graph, so that's 180 degrees. Remember, we're looking at 360 degrees, one kind of unit circle around, whoop, like this, going from 0 to 360, and we're looking at the values of cosine. All right, so at pi, which is the same thing as 180 degrees, where are we at? We're at -1. So if you plug into your calculator cosine of 180 degrees, you'll see the answer is -1. All right, now, so from here, we went from 0 degrees to 180 degrees. And what happened? Well, right here, these values, this is +1. This is all positive. Then we hit 0 right here. And then from this point on, we're in negative territory, right? Because this is -1. This is negative y-axis. So we're all the way down here. And so from 180 degrees up to this point in the graph right here, what's going on? Well, we're going to go from 180 to 3 pi over 2, which is the same thing as 270 degrees. This is still negative. But if you think about it, these values right here, like this value is 1/2. If this is 1, this is 0, right? So this would be like 1/2 right there. And then here is 180 degrees. That's 270 degrees, which is 0. Cosine, right? Cosine of 270, which is 3 pi over 2, is 0. And then finally, this one period here, or one wavelength of cosine is going to end at 360 degrees or 2 pi, okay? So at this point, we're back up at a +1. So let's look at our cosine 300 degrees. Where is 300 degrees? Well, if this is 270, and that's at 0, right? And right here, 360, we're already back up with our amplitude of +1, okay? Well, where's 300 degrees? Well, 300 degrees is going to be like somewhere in here, okay? So you can kind of look and just kind of estimate, well, it's going to be, this is in the positive territory here, right? We're above 0 and we're going all the way up to +1. So our answer has got to be positive. And you know what? Our answer, we already know the answer is 1/2, but you can kind of see, oh, like this is, this is 270. This is 300, so all of these is the degrees increasing, right? This could be like 280, 290, 300, 310, 320, etc., all the way up to 360. All right, now I spent a decent amount of time here, on this cosine graph because you need to be able to relate all these various concepts that you're learning in trigonometry. You got to learn the graph and think about the graph, in terms of your evaluating a trigonometric function. You got to keep all this stuff in mind. So you don't have to use the graph. May have just kind of learned that cosine, if we think about it, where it's at and what quadrant it's at, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Right, so this is 0 to 90, 90 to 180. We're talking about degrees, and then 270 all the way back to 360. Right here, let me go ahead and highlight that a little bit better. This is where 300 degrees is going to be, and it's going to be in quadrant 4. So some of you, I'm pretty sure if you're taking a trigonometry class, you'll know that the cosine is going to be positive in quadrant 4. Okay, so, but again, you don't want to depend too much like on rote memorization, right? Use the graph, use your understanding of the concepts you're learning. Okay, so a quick review on the cosine graph, and you can do the same thing. You'll need to understand the same thing with the other graphs as well: sine, tangent, all that good stuff, right? So yeah, there is quite a bit to learn in trigonometry, all right? The stakes are definitely much higher than, like, let's say, a basic algebra course. All right, so now what you want to do is draw yourself a nice little XY chart, and we want to plot 300 degrees, okay? And we're going to graph this angle. We're going to look at this angle in kind of standard position. So the standard position is where we start from a terminal side, which is the positive x-axis. You're going to start and you're going to go counterclockwise this way, okay? So if we go to 300 degrees, we're going to start at this kind of terminal side, okay, right here. And again, if you don't understand what I'm talking about, then you need to. I can't possibly teach you all of this in this one little video, right? I'm assuming that you have some understanding of this, but again, if you need like full-on instruction on this stuff, check out my pre-calculus course. Okay, so here you're going to start from 0. You're going to go counterclockwise all the way to 300 degrees. This is what, 90 degrees here. This is 180. Okay, we're going to do it this way, 180 degrees when we start this way, right? We're going 90, we would go 180. Don't confuse this with like like a compass, right, where you have north 0 9. That's not the case. We're starting here and we're going counterclockwise. So here's 270 degrees. So if we continue on and we pass 270 at 300, we're going another 30 degrees this way, right? So we went another 30 degrees this way. So we need to look at what angle is being formed with the terminal side. Okay, with the terminal side, that's this angle. So we know we have 30 degrees here because we're going 30 degrees past 270. That's the 300 degrees. So we're going to draw a little radius out like so. Okay, 30 degrees past 270. This entire angle is 300 degrees. And then you're going to form a triangle, okay? And you're always going to go back to that terminal side, okay? So from your radius here, you're going to form you're going to think of this as a triangle. We call this a reference triangle, and it's going to be perpendicular to that terminal side, that x-axis, and you're going to draw a line up like so. Okay, so now we have a lovely right triangle. Okay, now if this is 30 degrees here, what's this angle? And hopefully you can kind of see, and I know it's my drawing here is getting a little sloppy, kind of like erase this a bit. All right, so here we know we from 270 past, we go another 30 degrees past 270, we're at 300 degrees. So this is going to make this angle right in here 60 degrees. So we're dealing with a 60 degree and a right triangle. Okay, this is right because it's always going to be, we're always going to draw a line perpendicular to that terminal side. So this is the kind of the situation that we need to be thinking about. Okay, we have 60 degrees. It's a right triangle. So you need to be very familiar with these special right triangles. In trigonometry, you're going to use these things all the time. So you need to be a total expert with these triangles here. The 30, 60, 90 triangle, which is the one we're dealing with. And the other one you're going to have to be a expert at is the 45, 45, 90. Okay, these are the two primary triangles that you will be using when you're trying to evaluate a trigonometric function without a calculator. So if you know how to do one of these problems, you should be able to do all of these problems. Okay, so again, we'll take a closer look at the 30. This is 60 right here, so this would be 30, this is 90. You need to know how to solve 30, 60, 90 right triangles, something that you would learn in geometry. Of course, we are at the trigonometry and pre-calculus level. All right, now that we kind of looked at this, we know, okay, here is cosine of 300 degrees is going to be effectively the same as figuring out this reference triangle here, okay? Figuring out the cosine of this reference triangle. So we got to think about what cosine is again. So cosine is the adjacent over the hypotenuse. Remember our SOHCAHTOA. So this is going to be cosine is equal to adjacent over the hypotenuse. But we don't really think of cosine with respect of it being the adjacent over the hypotenuse in terms of unit circles and reference triangles. We think of that adjacent as being x, and we think of the hypotenuse as being r. Okay, so right here, this line emanates from the origin coming down like so. This will be our radius, okay? And then here we have some side of this triangle along the x-axis, and we have another side of this triangle along the y-axis. So we have r, x, and y. So your cosine, tangent, and sine will be defined not in terms of adjacent over hypotenuse. It's the same thing. It's still a trigonometric ratio, but you're going to be thinking of things in terms of x and r. So cosine of an angle is x over r. All right. Again, stuff that you should know at this level. All right. So now that we understand that we're dealing with this 30, 60, 90 triangle in this fourth quadrant, and we know the cosine is x over r, we can kind of take it to the next level. All right. So let me scroll down here. Okay, so remember we talked about a 30, 60, 90 right triangle. Okay, let's actually go back up here real quick and before I show you that work. So you need to know the basics of a 30, 60, 90 right triangle. I'm going to draw it a couple different ways, okay? And you got to know this like perfectly. So here, this would be like 60, right? We kind of identify which is the bigger angle. This is 30, okay? So what's the smallest side? You always have the smallest side of the triangle being 1. Now the hypotenuse, which is opposite of the right triangle, okay, the hypotenuse is always going to be the longest side of a right triangle, is double the base. So it's going to be 2. So if this is 1, this is 2. If this is x, this is 2x. If this is 4, this is 8. You get the idea. So the hypotenuse is always double, okay, the base, and then this medium side is going to be the square root of 3, or this side 1 times the square root of 3. Okay, now again, if you're not up to speed on 30, 60, 90 right triangles, you need to be, because they are extremely important. All right, so if you have your 30 degrees here and your 60 degrees here, we still have to be very aware of what's going on. So let's just do an example. If this was 3, what side would this, how long would this side be? Okay, well, this is the hypotenuse. This is the shortest side, so this would be 6. And then this medium side is going to be this number times the square root of 3. Okay, in this case, this is 1 times the square root of 3. But all you really need to know is this triangle right here. The 1, 2, square root of 3 is a 30, 60, 90. But you got to be super aware of what's going on in what quadrant. So here, we're in this fourth quadrant. Here's y, here's x. What's going on? Well, x is positive right here, right? This is positive x. And here, y is negative, right? This is negative y. So our y value is going to be negative here. R, okay, this radius r is always positive, okay? So what's going to change signs is going to depend upon what quadrant you're in for x and y, but r is always positive. Okay, so if you're completely lost, then what you need to do is go get my pre-calculus course, and in the my trigonometry chapters, look up evaluating trigonometric functions and kind of review from there. So yes, this is a lot to cover, but now let's go ahead and put this all together here. So here is our 300 degrees. Okay, we're talking about our reference triangle here. So we're trying to solve a 60-degree right triangle. That's what's being formed here. So let's take a look at the measurement. So this is the smallest side. We kind of have to interpret this here. So that's going to be 1, positive 1. The hypotenuse here, which is always going to be the radius, is 2. 1, 2. And then our y here is negative, okay? Because remember, y is negative here. So that's going to be negative square root of 3, okay? All right, so now remember cosine is going to be x over r. So what's x? Well, x is 1. Okay, this is what x is equal to because this is along the x-axis, and then r is this right here. It's the hypotenuse, and of course this would be y, but we need x and r to get the cosine. So cosine is x over r, so that would be 1 over 2, or 1/2. So the cosine of 60 degrees is 1/2, which that reference triangle is the same thing as finding the cosine of 300 degrees, which of course is 1/2. And we know in the fourth quadrant, cosine is positive. We already talked about that with the graph. Of course, you could have learned that just through rote memorization. And this is a positive value. This is a positive 1/2. Okay, so again, looking at a problem like this, I'm explaining things. Now, of course, I could have done this problem much quicker myself. Like, okay, here's how to do it, but da 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 da, 1, 2, 3. But I already know how to do it. I'm trying to teach you how to do it, right? So I'm going to be walking you through kind of, explaining things that I'm pretty sure that some of you out there are struggling with this may not fully understand. And how would I know that? Well, when you've taught math, not for years, but for decades, and you've graded maybe 100 million different quizzes, tests, homework, well, maybe not that many, but you get the idea. You understand where students' kind of weak areas are typically at. So if you're struggling with this stuff, what you have to do is ask yourself, are you missing some foundational, knowledge, or comprehension? It's likely that you are. So again, you can figure this stuff out, okay? But you're going to have to put the work in, and when you're putting your effort in, you're actually learning. Hopefully, you have great math instruction, so you're not confused on what you're being taught. Okay, it's already challenging enough to learn advanced mathematics, but if the instruction is already confusing, well, then you're gonna, in deeper trouble. Okay, so evaluating trigonometric functions without a calculator, something you absolutely guaranteed are going to be seen in your future. Not only in trigonometry courses or pre-calculus courses or like a calculus course, but these kind of problems oftentimes too sometimes show up on standardized tests, whether it be a teacher certification exam, SAT, etc. There possibly SAT, ACT, definitely like things like the GRE, GMAT. You could possibly see questions like this. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.